morning, everyone. Today we'll start replication. What is replication? What is replication? So replication means duplicate copies of same block. Duplicate copy of same block. Duplicate copy of same block is called replication. What is replication factor? What is replication factor? How many duplicate copies? How many duplicate copies is called? Duplicate copies is called replication. Replication factor. So the default replication factor is 3. The default replication factor is 3. But it is configurable. But it is configurable. Are you hearing me now? So, but it is configurable. So we can configure replication factor. So there is a file called hdfs-site.xml. hdfs-site.xml file. Here we configure replication factor. Replication factor. Here we configure replication factor. Okay. If we not specify any replication factor, then it will consider default replication factor. Default replication factor. So if you not specify anything in this XML file, then it will consider default replication factor. Yep, I'll explain here. So why replication factor? Why replication factor? Why replication or replication factor? Why replication or replication factor? Let's take one simple use case. RDBMS software requires high-end server software, high-end configuration hardware, high-end configuration hardware. Otherwise RDBMS crashes. So hardware cost is high, and RDBMS software is licensed every year. We have to renewal. We have to renewal. So if you are using RDBMS software require high-end hardware installation and using both. Okay. So if you want to use RDBMS software in production, we need high-end hardware. So otherwise, chances of crashes is high. So that's why we maintain high-end hardware in RDBMS. Coming to Hadoop, first of all, Hadoop is free. Hadoop is free. No need to pay. No need to pay license cost. Second one, Hadoop works on commodity hardware. Commodity hardware. What is commodity hardware? What is commodity hardware? Commodity hardware is normal hardware. It is approximately 20 times 20 times less than server hardware. Their cost is 20 times less than server hardware. So PC is less than commodity hardware. PC hardware is less than commodity hardware, and commodity hardware is less than server hardware. So instead of buying one server hardware, we can buy 20 commodity hardware systems. So first, software is free and it is working on normal hardware. So this is the advantage of Hadoop. Yep, it's a cheap hardware with low configuration. Configuration is high. Configuration in the sense RAM, hard disk, CPU. These are we can use high hardware, high configuration systems, but low cost. Low cost. So so chances chances of failure is high compared to server hardware, right? Compared to server hardware. So chances of failure is high compared to server hardware. So to resolve this problem, so to resolve this problem, this problem, we maintain multiple copies of same block, multiple copies of multiple copies of same block. So that's why we use replication factor. So if one block is failed, we can access data from another block. Okay. Compared to server hardware. Server hardware failure is very less because it is high-end hardware. So it gives reliability, but normal hardware failure chances are high. So that's why we are maintaining multiple blocks, multiple copies of same block. Okay. Next important one, uh, under replication. Under replication. So before discussing under replication, let's once again see how file is placed in Hadoop cluster. So assume we have 6 slave missions and 1 master mission. So this is name node and data node 1, data node 2, data node 3, data node 4, data node 5, data node 6. So user wants to place file. So this is client system. Client 1. Client 1 wants to place file. So file 1, name is file 1, and even, this file contains 300 MB. So this client want to store file into Hadoop cluster. So first client send a request to name node. So name node prepares what? Metadata. Name node prepares metadata. Name node prepares metadata. So this metadata based on replication factor, based on block size, based on replication factor, based on replication factor, replication factor, and based on proximity algorithm, proximity algorithm, it prepares what? Metadata, right? So it is preparing metadata saying file 1, block 1, and data node 1 comma 2 comma 3. File 1, this is assumption, okay. Block 2, 2 comma 4 comma 6. File 1, block 3, 3 comma 4 comma 5. Assume it define this metadata information. Data node 1 2 3, this one data nodes information. I said in previous class, metadata means sorry, mapping between file to block and block to data nodes, data node list. I think you may missed previous class. So it is a mapping between uh, file to block and block to data nodes list, okay. So then client performs what? HDFS write flow. This process is called HDFS write flow. In this HDFS write flow, so first block 1 is placed in data node 1, data node 3, data node, okay, 1 2 3, 1 2 3. So block 1, and block 1. Next block 2 placed in 2 4 6, 2 4 and 6. So this is assumption. Next block 3 placed in 3 4 5, right? 3 4 5. Block 3, block 3 and block 3. If this mission is down, we can access block 1 from data node to data node 3, right? So that's why we are maintaining multiple blocks, okay. Let's coming to under replication. Under replication. What is under replication? So if any mission is down, if any mission is down, then if any mission is down, simply we say the blocks, the blocks which are less than replication factor, less than replication factor. Replication factor is called under replicated blocks. Under replicated blocks. Under replicated blocks. So first one here, one of our student question is how name node knows about system crashed or not. So for that one, I'll explain heartbeat signal. Heartbeat signal. So let's wait a few minutes. We'll discuss what is heartbeat signal. So first, let's understand briefly. Every slave mission sends heartbeat signal to name node, so that name node understand data node live or not. Okay, this heartbeat signal contain information. Okay, next one, name node prepares metadata and sends this information to client. Client is responsible to write data into slave missions. So here we'll discuss what HDFS write flow. In this write flow I will explain how blocks are going to write into data nodes list. Data is writing in parallel fashion, so I will explain how data is going to write into Hadoop cluster. Okay, yep. So block 1 is under replication factor, right? Then whenever any block is under replication factor, sorry, under replication, it maintain one file under replicated blocks. Name node maintains under replicated blocks file under replicated blocks. In this it maintains what? Under replicated blocks. So B1 is under replicated block. For file 1, for file 1, B1 is under replicated block, right? In under replicated block situation, name node ask any one slave mission to replicate this block. In under replication situation, in under replication under replication situation, in under replication situation, name node request name node request slave missions slave missions slave missions to replicate this block, to replicate this block. Assume data node 6 accepted to replicate block 1. So assume data node 6 accepted. Which one accepts first, then that node is replicates that block. So block 1 is replicated in data node 6. Block 1 is replicated in data node 6. Then it changes this entry. It changes this entry and adds what? 6. Okay, it modifies metadata. Once data node 6 is accepted, once it is replicated block 1, it modifies metadata. It removes entry of this one. Okay, then so one important note here, at under replication situation, at under replication, at any situation, name node tries to achieve replication factor. Name node tries to achieve replication factor. First important point is name node tries to achieve replication factor. Next, over replication. Over replication. After some time, assume we have hardware administrators, hardware admin, and we have operating system admin, and we have network admin, and we have Hadoop admin, Hadoop administrator. So we have different administrators working. If it is hardware issue, then hardware administrator resolves the issue. If it is operating system issue, operating system admin resolves the issue. If it is network related issue, network administrator resolves the issue. If it is hardware Hadoop related issue, Hadoop administrator resolves issue. Then finally, after issue resolve, this one become up, right? This one become up. So this become up. Then data node 1 communicating with the name node, communicating with the name node. So whenever data node started communicating and sending this blocks information to name node verifies metadata. Name node verifies metadata. So block 1 is already presented with 3 replication, right? So block 1 is presented already 3 replication, but it is additional block, right? So the blocks which are greater than over replication means the blocks which are greater than replication factor. Replication factor is called over replication. Over replication. Over replication. I said at any situation, it may be over replication, it may be under replication. Under replication. Then name node tries to achieve replication factor. Replication factor. Okay. So in over replication situation, again name node request data node 1 or data node 2 or data node 3 or data node 6 to remove over replicated block. Over replicated block. Name node request data node 1, data node 2, data node 3 and data node 6 because these 4 missions contain block 1, right? That's why it requests anyone all these 4 missions. Which mission accepts first, block is removed from that mission. Assume data node 1 accepted request, then block 1 is removed from data node 1. Okay. So most of the times whatever the node is come up, then that will accept request most of the time. Okay. So this is accepted request and this block is removed from data node 1. So we have 3 blocks for file 1, block 1. Okay. For block 1 we have 3 copies. Heartbeat signal. So there are 2 types of heartbeat signals. There are 2 types of heartbeat signals. One HDFS, second one MapReduce. HDFS heartbeat signal. Every data node sends heartbeat signal. Every data node sends heartbeat signal to every data node. Every data node sends heartbeat signal, heartbeat signal to its master node. Its master node. Master node is here name node. Name node saying status and number of blocks presents, number of blocks presented. So every data node sends heartbeat signal to its master mission saying status of that mission and number of blocks presented in that mission, number of blocks presented in that mission. Number of blocks presented in that mission. So in this heartbeat signal, it will send status as well as number of blocks presented in this mission. Okay, this will happen in every 10 minutes. Every 10 minutes, but it is configurable. So in hdfs site.xml file, site.xml file, we will configure total blocks. Yeah, here one of our friend question is here. I said how many blocks are presented in this mission. It sends only these blocks information. So data node 3 contain how many blocks? 2 blocks. Okay, it sends 3 blocks. No, there is no limitation. So in hdfs-site.xml file, we will configure heartbeat signal interval. If we are not configured, then it will consider default. So default is every 10 minutes. There is one special concept called block scanner. This block scanner presented in every data node. It scans blocks. So responsibility of block scanner is it scans blocks. So there may be a chance of correction of this one disk, right? Disk. So hard disk may be chance of corruption corrected, right? So in that case, assume this memory is corrupted. The block B1 presented in data node is corrupted. Some part is corrupted. Then, so we can say this is not a complete block, right? So in that case, so in heartbeat signal, data node saying only block 3 information. Then name node verifies how many blocks are presented in data node 3. Data node 3 presented block 3 as well as block 1. So block 1 it's saying only I have block 3. Then it maintain over replicated under replicated block file. In under replicated block file, it places block 1 and requests any one mission to replicate that block. Okay. So in MapReduce, heartbeat signal, in MapReduce heartbeat signal, every task tracker sends heartbeat signal to its master. So its master is job tracker. Its master is job tracker, saying status and number of jobs execution status. Assume we have job tracker mission. Assume we have job tracker mission. So processing request came. Example, select star from EMP where gender equal to male. So this request is came to job tracker, and job tracker assigned task to assume it assigned task to for block 1 processing this task tracker mission. So task tracker is presented, and block 2 processing, for block 2 processing it assigned to data node 4. So here we have task tracker, and block 3 to process block 3 it assigned processing request to this one. So here also we have task tracker. So these three are parallelly processing this block 1 and block 2 block 3. So every sometime, like it has a default 10 minutes. So every 10 minutes our configured value, it will send status to job tracker. I am alive, I am executing block 1. Block 1 is completed 50%. And this task tracker saying I am alive, I am processing block 2, 70% is completed. Then this one is saying I am alive, I am executing block 3 completed. So every task tracker updates its status to job tracker. Okay. In MapReduce heartbeat signal, every task tracker sends heartbeat signal to job tracker saying status of that mission and number of jobs executing plus status of each job. Okay. Yep. In second class, I think in Hadoop architecture, I explained it is recommended to run job tracker in separate mission and recommended to run task tracker and data node in same mission. Okay.